Assalamu alaikum friends, this is Ishfaq Ahmed. Let's today talk about mathematical identity, that's Euler's identity. It's of course one of the interesting mathematical identities in the whole mathematics. Let me first recall for you how do we analyze or how do we observe mathematics as a whole. We say that mathematics is something which not only has the highest relevance to our routine life, but it is something which interferes in almost every aspect of our universe. For an ordinary man, we say mathematics is something about calculations, countings, measurements, constructions, geometries, but the scope and the field of mathematics has largely widespread now. It's in a sense it is organizing our businesses in a way that we have maximum profit with the minimum loss. It is performing tasks in a style that it takes us minimum time, but we have to have minimum efforts with maximum gain. In a sense, it's performing tasks in such a fashion. As a whole, it is about solving varied type of problems in different fields. But how does mathematics perform this all job? It is done through the mathematical rules, techniques, formulas, equations, identities which are there. But we're today going to talk about a beautiful mathematical equation. Could be an equation beautiful or interesting, but what is the parameter for an equation to be the beautiful? What are the ornaments of the beauty for an equation of these jewelries? Let's today talk about one such equation, that's Euler's identity. We're going to interpret how a compact sized equation could be so beautiful that someone could say that it is the most beautiful mathematical equation. Let's go.
Okay friends, now here we go for the actual Euler's identity, Euler's identity. But for this I have to mention first Euler's formula. As Euler's identity is basically an entirely deduction of Euler's formula. It's one of the known formula in the complex analysis. Let me just state it. It stated that, I have to assume that you are informed about it, for every say x in R, that's for every real number, e power iota x is equal to cos of x plus iota sine of x. If we are going to take a particular value of this Euler's formula, from this Euler formula, we take x equal to pi. हम x का वैल्यू जो है पाई लेते हैं और देखते हैं कि हमारी इस Euler formula को क्या हो जाता है. Let's go for it. We will see that we have e power iota pi. This is going to be then cos pi plus iota sine pi as x is equal to pi. Here you have to check cos pi. Cos pi means cos 180. If you are knowing from the table cos of 180, this is used to be -1. And if you are informed about sine pi, it's the rule that sine n pi is used to be 0. मतलब ये हमारे पास पहले ही वैल्यूज है, ये चीजें हमें पता होनी चाहिए Euler's आइडेंटिटी के लिए. तो we get e power iota pi is equal to -1 plus iota into 0. So it's simply equal to e it implies e power iota pi is equal to minus. From this you can see that e power iota pi plus 1 is equal to 0. It's what we call as Euler's identity. So simple and so short, what we call so compact. But what is so such in it, by which we say that it is, someone says about it, that is the most remarkable formula. Basically, this Euler's identity was deduced from this Euler formula in the year 1748. Okay, as it's a, so this Euler's identity is a deduction of this one. But if you can check here, why is it a perfect example of mathematical beauty? This identity contains 5 numbers. If you can check these, this is 0, this is 1, this is pi, this is e, this is I. But just concentrate upon these. How much you know about these numbers? But at least you should be knowing that these very 5s are the fundamental constants in the whole mathematics. So in a sense, you have got a formula, you have got a relationship which is so compact, but it is in a position to hold all the fundamental mathematical constants. It is the beauty of this formula. But let me, for your information, mention here one by one what are the features of these numbers. Let me first inform you what is 0 in mathematics. It is in case of our number system, as we say, it's our additive identity, isn't it? Additive. And you know that the identity is used to be, for an operation it is used to be unique. If we go for 1, what it is? It is multiplicative identity, isn't it? This is also unique for a number system under any operation. What do you know about pi? Yes, we know that this is basically circumference of a circle divided by its diameter. That's 2 pi r divided by 2r. As 2r and 2r will cancel, we get pi. Okay, but you should be knowing that this pi is a transcendental number. That is, it cannot be root of an transcendental number, and it is also, when it is transcendental, it has to be irrational. You should be knowing that it's a transcendental and irrational number. It is a constant. In a way, it's very famous as well as very important, very significant number in case of whole mathematics. If we go for e, this is basically also an Eulerian or Newtonian constant. This is used to be equal to, we usually write this pi is equal to approximately 22/7. This too, we write its value is 2.718 and then continue. We also know that this is a transcendental number. That is, it cannot be root of any polynomial, so it is also irrational. And also you should be knowing that it is base of natural logarithm. And if you know about I, this is used to be equal to under root of -1. This was the basis of the whole complex analysis, and you should be knowing that iota square is used to be -1. It's the imaginary unit. That's how we are able to generate from these 5 fundamental constants and such an interesting and such a beautiful mathematical identity, Euler's identity. You can notice here, I would like to mention it here, that this Eulerian identity is compared with a Shakespearean sonnet. and someone named physicist Richard Feynman says about this Eulerian identity that it is the most remarkable formula, or what we call identity or equation in mathematics. Why? Because on the base being so compact, it contains 5 fundamental math constants. And the formula holds. It is all what I have to say about the Eulerian identity. Hope that this will be also interesting for you. Thank you for watching and being with me.